Good afternoon, everyone. That's called optimal demo preparation. Just a minute before the talk gets started, we're done. So efficiency. Anyways, my name is Subramanian Ramaswamy, and I'm going to be talking about Azure Service Fabric, how it is a container orchestrator built for scale. And since pretty much only my parents can get the pronunciation of my name right, I go by a shorter name, Mani, to make it easier. And I can assure you that running 1 million containers on Service Fabric is a lot easier than getting the pronunciation of my name right. OK, so with that, let's get going. So how many of you were at Mark Rosinovich's talk yesterday? Not a few. Very few. OK, so this is all going to be new stuff to you. So I am actually going to be showing you the same demo that Mark showed in his talk, which is orchestrating 1 million containers real-time on an Azure cluster in front of you. So jumping into the agenda, so what am I going to be talking about? So firstly, I'm going to give a very quick, brief introduction to Service Fabric, maybe 5-10 minutes for folks who are not familiar with what it is. Then I'm going to talk about container orchestration at hyperscale, how Service Fabric is built to have clusters of thousands of nodes, runs millions of containers, and on Linux or Windows, pretty much anything you can throw at it. And how it's essentially, that goes to my next point, which is basically it's any cloud in your operating system. So you can run whatever service you want, whatever language you want, whatever framework you want, and whatever operating system you want, and wherever you want, whether it be on-premises, in your dev box, or on the cloud. And then in the latter half of the talk, I'm going to be talking about Service Fabric as a data-aware container orchestrator. It's the only data-aware container orchestrator that is available there. So I'm going to give you a peek into some of the key differentiators that plays it apart from the other orchestrators, how it handles data and stateful stores mainly. Now I know that all of you came here to hear me drone on and on and on, but I'm sorry to disappoint you, but this is going to be a demo-intensive presentation. So you're going to see a lot of demos. You'll hear me talk, but you'll see demos too. So sorry again. All right, so let's go into Service Fabric. A very quick introduction into what it is. So when it comes to container orchestration, this is kind of the state of the world today. Like, you mix and match. Some people want flexibility, so you mix and match a lot of these technologies or tools that are available to solve the problems on the left-hand side. Like you need rolling upgrades, you need availability, you need state stores. So you use a lot of these together, and you put together your own path, essentially. Now, the key here is you get a lot of flexibility, but on the other hand, there is no integrated solution. There is no one person who actually, or one org that controls the entire package. So with Service Fabric, what you're going to get is an integrated solution. It's an end-to-end integrated solution. We take you right from developing your microservices, lift and shift your existing microservices and containers, as well as actually run them in Azure or pretty much anywhere. And it solves all the problems that I talked about earlier, like from rolling upgrades, availability, scale, on-demand, stateful workloads, leader election. All these hard problems are solved by Service Fabric in one package solution. And it is very versatile in the sense that you can run it on any OS and any cloud. So this honeycomb essentially shows some of the features of Service Fabric. Lifecycle management, where you get zero downtime upgrades. I showed a demo of this yesterday at a different talk. Container orchestration and microservices orchestration. We were an orchestrator before orchestration was cool, so to speak, because we've been running some very heavy first-party workloads, as I'll show in the next few slides. We have built-in programming models that you can use off. If you want to write a distributed application from scratch, where do I start? Well, we help you. We take you through some easy distributed programming models, distributed programming paradigms that help you create cloud-native applications. Health and monitoring is also built in. I'll show a couple of demos of that as well. And it scales on demand, and it's built for scale. You can run the same code on, and the other thing that I want to say is you can run it pretty much anywhere in the sense the same code runs across all the layers on the bottom. So whether it be your single box developer environment, or whether it be Azure, or whether it be your on-premises data center or on Azure Stack, or whether you are actually running it on other clouds that we shall not name off. So it runs the same code everywhere, and it gives you the same experience everywhere. So as a dev, I can actually run everything and test everything and debug everything on my own machine, like it would run in Azure on a 5-node or, say, a 2,000-node cluster. So very quick introduction again to Service Fabric. So what is it? Well, it provides a clustering manager, so it creates a pool of resources, it ties together a bunch of VMs and calls them one cluster. So you interact with it through one endpoint, everything goes through one endpoint. You really don't care about what the VM IPs are or what the VMs are anymore. Everything goes through one endpoint. Environment abstraction, so you can run it anywhere. If you write using our programming models, you can pretty much run it anywhere, as in any OS, or pretty much any data center that you want. Always-on availability is built as a self-healing platform, so it always detects failures. So one of the things that people don't realize is when you're having, say, 5 machines, and each machine has a 99% reliability, when you have 5 machines stitched together, your reliability is actually only 0.99 raised to 5, which is actually 95%. So because the chances of one of the components being down are higher. And Service Fabric is built to handle those kinds of scenarios. And obviously, orchestration, this is kind of the bread and butter that we've been doing for almost 10 years now. You manage resources. You can dynamically apply placements. That is, hey, I have multiple node types. I want this workload to be running on this node type. You could do those kinds of things. Management, again, zero downtime upgrades. And you can, of course, and Service Fabric also provides a built-in rollback. Like if your upgrade actually goes wrong, in the sense you do an upgrade and then Service Fabric detects, hey, something is bad, like it's taking down nodes or your process is actually crashing on launch, Service Fabric will automatically roll back the upgrade to the previous functioning state. Again, configurable by you. And you can also tell Service Fabric, hey, there is this throughput metric that I need to hit or a latency metric that I need to satisfy. And if that is not happening, please roll back the upgrade. That can also be done. So everything, it's versatile. It's all configurable according to your needs. It's a first-class microservices application platform. So in addition to being a container orchestrator where you can lift and shift whatever you want, you can also develop programs, cloud-native programs from scratch, whether you run them inside containers or outside containers. Again, I'm going to talk, my second half of the talk is going to be mostly about how we do stateful stuff. So in the orchestration world, state is kind of a problem that people are starting to hit the edges of and starting to think about it. How do we manage state? Oh, if I want to run something and my front end is all stateless, so it's all wonderful. But I have to set a MongoDB cluster up or a Cassandra cluster up, and then I have to deal with the replication of it. I have to configure it. Every time a node goes down, I need to do something about it. So people are still only scratching the surface of what it means to have a high availability application that has state in it. With Service Fabric, we've actually solved this problem several years ago because SQL databases actually use our stateful paradigms. And again, so what we are trying to make is, while we have the existing programming models and everything that actually make handling stateful workloads a first-class citizen, we're actually going further in actually making it very easy for you to lift and shift your existing container workloads, even if it is not using our state store directly. Say, for example, you're using some NoSQL database, we can still provide our state store to actually provide high availability easily through a block store that we have actually exposed, which is built on our state store. So I'll talk about that later. Everything comes with end-to-end tooling. So you have IDEs, you have Eclipse on every platform, you have Visual Studio, Visual Studio Code, PowerShell, CLI, dev boxes. You can do it on Mac or Linux boxes or Windows boxes. Chaos testing. So what we do is, this is essentially, if you've heard of Chaos Monkey, we actually have an inbuilt service that actually does it. Hey, takes down random nodes here and there. So let's see what happens to our service when something like this happens in the real world. So the key here is Service Fabric is an integrated solution. So it's a true PaaS solution in the sense it solves all these problems for you in one big batch. So if you run into a problem anywhere here, you can pick up the phone and you can call me. And by that I mean, do not call me. Now, like I mentioned, some of the first-party workloads that are running on Service Fabric. So when you look at the scale of some of these things, SQL is pushing about 2.5 million databases. Event Hub's now trillion events per day it's handling. Cosmos DB runs on this. IoT Hub runs on this. Pretty much, the key here is Microsoft first-party services. I don't know if you saw Jason Sanders' talk yesterday where he was saying everything in Azure, like he runs on Service Fabric. He's constantly, I think the term he used is constantly firing bullets at it, and the platform just withstands it. And when you're running at scale, it is something that the platform has to withstand because hey, when you're running, say, several thousand nodes, some nodes are going to go down, some hard drives are going to fail. So how do we, so the platform should handle it. So you can see pretty much all major Microsoft first parties actually run on Service Fabric. So you could pretty much say Microsoft runs on Service Fabric. Just to give you a feel for some of the scales that we actually hit, this is an aggregated scale, so millions of cores, millions of services. We see service upgrades that are happening on the millions weekly, trillions of transactions per day, clusters with thousands of nodes and thousands of workloads per node. And of course, everything has to be reliable and available. So literally, detect and handle failures within seconds and no downtime upgrades or zero downtime upgrades. So all this is handled by Service Fabric today. And in the course of this, I will actually show some of these examples on a single cluster, this aggregated scale. So before I actually show the million containers, which is what most of you are here for, I realize that. I'm not giving away the ending until a little bit later. So how we got to here is we have years of learning running all these first-party services. So if SQL database had a data loss, for example, I would probably not be here. I wouldn't be having a job probably. So it's kind of with years of experience running these highly intensive, high-density, at-scale services. So it made sure that our muscles were exercised in withstanding these loads. It's not like when we started 10 years ago, we didn't have any issues. Obviously, we did. But we helped solve their problem because they wanted to get out of the business of orchestration and managing the machines and doing all these things. They want to leave the platform building to us, and they want to focus on their business logic, which is the database, and not on these things. And the same problem was happening across the company as well. And so that's why we invested in a first-class platform that handles the scale. And so it solves all these problems, and we learned from our first-party services. So, hey, what I tell customers, hey, if it's good enough to run SQL, it's probably good enough to run your workload. Very few workloads are going to come to that scale or density. So mostly, it's rehashing the same thing that I said. Like, we have mission-critical application upgrades. If an application upgrade goes wrong, let's say SQL got upgraded and you lost your data, not going to be very pretty. Hacker News is probably going to be all around it, all over it. So, and like doing this, we have to factor in all the orchestration primitives, like handling services, handling placement constraints, resource governance, state store, all of these things we have to handle because from our learnings. And it's optimized for performance. It has to be. If it's not, no one wants it. So with that, let me first go into one of my first demos, which is actually I'm going to take a container from scratch, and I'm going to run it in 2 minutes. So what I'm going to do is I'm going to open up a Cloud Shell, and that's how I'm going to connect it. So let's actually shift here. Okay, I think my session got disconnected, so let's see if this comes back. Pardon? Yeah, I'm going to make it a little bit bigger. Okay. So what I'm going to do here is, this is Cloud Shell, so I'm just using Azure and using the, the Cloud Shell, and then starting Bash here. So I'm going to just, before I start, just to explain what I'm doing is, I'm just going to copy a git clone at a repository, then run install to a Service Fabric cluster. And the way I'm going to create a Service Fabric cluster is, I'm not actually going to create a cluster. There's a service that we provide called Try Service Fabric for free. And I'm going to get a cluster endpoint from there, point it there, and deploy it and show you the app running. So let's actually get going. So since I've run this a couple of times practicing, so it's just cloning into the directory. And okay, it's now cloned into the directory. Now what I'm going to do here is, I think this is the next. No, DNS sample. Okay. So I have a script here. When you clone the repository, you actually get a script. So what the script does is just application upload, provision, and create. So now what I'm going to do is, I don't have an endpoint. I don't have a Service Fabric cluster set up. So I'm going to go to this address, which is try.servicefabric.azure.com or ak.ms/tryservicefabric. And I'm just going to say, hey, I want to join a party cluster, which is a free cluster we give you. So I'm clicking on, come on. Okay. Now, with the 2 minutes, I didn't account all these non-controllable things, but the end-to-end is still 2 minutes. 010492. All right, now it gives me the option, hey, do you want to join a Windows cluster or Linux cluster? I'm going to choose Linux. So. Okay, so it gives me actually a cluster that is pre-provisioned and ready for me to use. So this is the Service Fabric Explorer endpoint. It's showing me, hey, I have a 3-node cluster. The minimum nodes that we recommend when you're running production is 5 nodes, but this is because it's a party cluster, we just have 3 here. So 3 nodes, no applications, nothing deployed to it. So let me actually grab the endpoint here. So this is the endpoint. And what I'm going to do here is do a cluster connect, sfctl. Let's do this so that I don't get into weirdness while typing. And I'm going to put this in. And so it's going to connect to that cluster as we speak. And it's a 3-node cluster, so the next command, once it connects, oops, I think I put an additional slash there. Oh, no, it's fine. Okay. sfctl, I'm going to do a node list. So it's going to show me there are 3 nodes there, so not very interesting, but just showing you that I did connect. Now all I'm going to do is do an install.sh. So what it's going to do is going to upload the application, create an application, and start it. So in a few seconds, you'll actually see this getting refreshed. You'll see, let's actually move this here. So you'll actually see the application getting created in real time. And the application will soon launch. So the application is ready. And it now starts the services. And there we are. We're almost there. So now let me actually just hit the endpoint. And I'll show you that the application is up. I missed an L here. It'll take a couple of seconds for Docker to actually, now what it's doing right now is, if I actually click on it, it's probably going to show it's in build. It's going to take a few seconds for the Docker image to be downloaded to those nodes. So it's actually doing it. Because all what my application has, because it's a container application, is, hey, these are the Docker images I need. Just there's a front end and there's a back end. Front end Node.js, back end Python. Get it, and then launch it. So now it shows it's ready. So it's ready. This guy is also probably ready at this point. So now if I refresh this, it should be able to hit the endpoint once the load balancer clicks in. Oops. I can't seem to type for the. And, well, this is the back end. It's taking a few more seconds because the load balancer still has to. So the load balancer probe is actually monitors it every 30 seconds. So it's going to take a few more seconds for it to show up. Unless I actually typed something wrong here. I think I might have gotten the endpoint wrong. So. I know what I did. Okay, anyways, ignore that, because what I did is I hit the endpoint, I configured the endpoint differently, and that's why you're not able to hit it. And I haven't opened that port up yet, 4000, so that's why. Anyways, but the key here is I was actually able to copy the application, provision it, and deploy it all within a matter of seconds. If I had provisioned the port correctly, you would have actually seen it actually running right now, and you would have actually seen the endpoint. Now let's keep going. Let me switch to 5. Okay. So that's what essentially I did. Like, I brought up a container application in 2 minutes. I couldn't show you the endpoint because I hadn't opened the port, but if I had opened the port, then you would have actually seen it as well. So basically lifted and shifted the existing apps into containers. I operated it with CLI in this case. You can do it with PowerShell as well. And the other thing we also offer is you don't have to use Service Fabric application manifests, or you don't have to use our schema. you can actually bring in your Docker Compose files and you can just run it. And finally, it's the same runtime experience, whether it be Windows or Linux. It's going to operate pretty much the same way. Now, a couple of seconds on this, just a few container orchestration capabilities. So deployment happens in seconds. I deployed a container application in a few seconds. You can see an Azure Friday video or the talk yesterday to see a bunch of these things in action, like scaling in, scaling out dynamically, applying placement constraints dynamically, using some of these features that are provided here. So it also includes, the bread and butter of container orchestration, like built-in DNS service, all those kinds of things. We orchestrate both Hyper-V and Windows Server containers in addition to Linux Docker containers. We understand, especially, security is a big concern. So Service Fabric supports GMSA, group managed service accounts, as well as certificate management for containers, where the certificate doesn't have to be baked inside the container. You can actually tell us where your secrets are stored, and Service Fabric, the cluster runtime, will actually manage taking that certificate and exposing it into the container at runtime. So nothing has to be baked into the container. Secrets can be outside the container. Finally, we also do a whole bunch of things, like we support an IP per container. So it doesn't matter if all your, say, you have a front end that listens to 80, and you say, hey, I want to create 1,000 instances of my backend that are all listening to, say, port 8080. And I have multiple applications running. All of the backends are actually listening to port 8080. How do I avoid port conflicts? You don't have to worry about it, because Service Fabric will actually provision an IP per container. So right now it's a dynamic IP. In the future, it will actually be a stable IP as well. So there is no conflict, because, hey, IP1 is using, container 1 is using IP1 colon 8080. Container 2 is using IP2 colon 8080. We will also soon support a virtual network per application. So even if you have multiple, this is basically our one of the aspects for hostile multi-tenancy. So if you have multiple applications running in the same Service Fabric cluster, they can't see each other. They can't do anything to each other. So it's an isolated network per application. And the next thing I'm going to show is basically a little bit of how we do monitoring and capturing diagnostics. And after that, I will show the 1 million container one. So let me shift to this view. Hang on a second. And of course, it's going to ask me to do two-factor again. So
what's the name of that segmentation you just mentioned? Hostile something?
Yeah, hostile multi-tenancy you mentioned. So the VPNs that will be coming in the next few months. So not now. Okay, give me a minute when the network actually kicks in and I get a notification. There it is. See, we are a secure cloud, so we make sure there is two-factor authentication whenever you change your network. So it kind of it's a little bit of a bummer when you're doing live demos, but other than that, it's a good feature to have. Let's do this. I think I'm having some network latency here issues as well. Let's see. Come on. I'm definitely having some network latency. Let's see if I have it. Here. Maybe I have it here. Okay, it's here. So this is just the OMS dashboard. So it's pretty much the same dashboard for Windows and Linux. This dashboard, what I'm going to show is with Linux containers. I can show it for Windows containers too. So there is this dashboard is going to be getting released in a week or two, I think, a couple of weeks. So you can just click on the Service Fabric monitor, and it's going to load you a bunch of details. So it's going to tell you what's happening with your Service Fabric Linux cluster in this case. So let's move it here. Oops, too far. So I have two containers running on this, and it's telling me, hey, there are two instances. One is a Redis, and one is an Alpine image. And if I wanted to see more information, I didn't intend to click that. And it gives you a whole bunch of information. That's the big story here. And it also gives you a bunch of sample queries. So this is something that we plan to fill in based on feedback. So the more you are using certain queries and you find more value for some of those queries, we will add them here. So here I'm just going to click a container node inventory. It's just going to tell me what the information of the containers that are running there. And it's basically telling me a bunch of information about the containers. Of course, the orchestrator is Service Fabric, it says. And this is Linux. And of course, you could there's nothing that prevented you from looking at Docker logs. So if you go back here, container logs, this is Docker logs. So it tells you how many logs you're getting in std out, std error, those kinds of things. And also it gives you an operational channel view. So what is happening with your cluster? Like did a cluster upgrade happen? Did something else happen? Like events that is very useful for you to know what is happening. Did an application upgrade happen? Those kinds of operational events are also presented to you in the same view. And again, this is the same for Windows and Linux. So this is a Linux workspace. So if I change my workspace to show a Windows cluster, let's select this one. And in a few seconds, there's some, as I said, there's some latency issues here. So, and this one actually, earlier, if you notice, there were 2 containers. This one actually shows 5 containers because I have 5 instances running of the same of the container. And if I go here, like Fabricam is the container that is running right now, and essentially it's the same view. So you get the same operational channel data, you get container logs. So it says 25 events in std out, so you can look through that if you wanted to. So it lists me all the container logs, like what's happening here. It's the same view for both Windows and Linux. So it's all integrated. So it's done for you by default. Now, let me actually switch back to my slides. And this one's what I did. Now, let's actually talk about the one that you actually came here to see. So container orchestration at hyperscale. So before I go into this, I just want to tell you what the setup is, so you know what's happening here. So what I have right now is, there are 3 services that we need to think about. One is the actual container services that I'm going to launch here. And on every node, I have a counter service that is aggregating, that's hearing from the container services. Whenever the containers are up, it will ping the counter service and tell it, hey, I am up, I have launched, I'm all good right now. And at that point, the counter service increments it. And the counter service finally keeps reporting it to an aggregator service, which reports the overall container count. So the cluster that I'm going to show you is going to have 3,500 nodes. And I'm going to launch 1 million containers, essentially. So I'm going to run a script that's going to launch containers. And the counter service is going to count. Whenever the containers get up, it's going to ping the counter service. Counter service reports to the aggregator service. So let me actually again. So this is the cluster. So very small cluster, 3,509 nodes. So the 9 nodes extra is because we wanted to separate out the Service Fabric system services and keep 3,500 nodes for just launching containers. I'm going to launch about, randomly about 330 containers per node, just because we can. That's about it. We could actually go a lot more, but we just did 30. And I have explained the application to you, so you'll find this is what you're doing. And on the right-hand side, you actually see the container count. So the idea here is when the containers actually start running, you'll actually see the graph going up from 0 to, the graph right now, how much does it show? It shows 0 to 1, and we'll see that actually going to 0 to 1 million. But since this is kind of a little bit of a dry thing to see, so what Mark Russ showed, and I'm going to show the same thing as well, especially with Cassini and Saturn being so much in the news lately, we decided, hey, wouldn't it be cool to have actually particles accrue to Saturn's rings, and with each particle being like 10 containers, and then have the aggregate count show there. So now, with that, I'm going to launch the script. So let me actually launch the script. It helpfully closed my remote desktop window, so you'll have to wait for a second here. Of course, it's going to ask me for the two-factor auth. Continue. Any second now. There we are. Okay, so I'm just going to create containers now. So you already saw a few services that are running there, but that services were not containers. They are just the setup services, so we can count the number of containers. Now, enter. Okay, now let's go back to the Saturn. Okay, a few seconds, you'll actually see the count starting to go. And if you have a stopwatch, you can use it. So you can see, it's doing it in batches. And what you're going to see here is, since this is kind of a perf test that we're doing, we're going to overshoot 1 million. We're going to go for a little more than 1 million so that, hey, what's the fastest that Service Fabric can actually spin up these containers in parallel? How fast can it do it? And as I said, like each of those particles that you see accruing to Saturn's rings is about 10 nodes. So Mark Russ said, hey, this is a world record attempt, and it is a world record attempt. Our nearest competitor, did I think they took like 1 million. Some of the competitors only did about 100,000. One experiment I know went to 1 million, but that was with 5,000 nodes, and also they just scheduled it. In this case, what we are saying is, we are scheduling it, we are placing it, and the container has launched. Only then does the counter service actually say, count that container as up. The container has to wake up and has to ping the counter service. Otherwise, it's not counted. So placement and scheduling is not what you're showing. Placement, scheduling, and launch times. Okay, 650,000, just a little bit more to go. And you're going to get there now. And I'll show you how much time it took as well. Because I just have to go back to the previous chart to show how much time it was taking. 800,000, almost there. And again, I want to be very brief because this is a very important, pertinent point that we are not just counting scheduling and placement. We are actually counting launch, meaning the container is up at that point, up at that instance. And we are there, 1 million. So let's see how much time it took. This is approximately, well, if I hover over here, it's approximately about, it tells me 246.25, and this guy is about 248.20. So little less than 2 minutes. So, launching 1 million containers took less than 2 minutes. And as I said, we overshoot it by a bunch more than 1 million because we are starting all these things in parallel. And so, we can do this as a perf test. So that's that. I kind of expected dancing in the aisles, tears. Now let me go back to my slide. You guys are way too cool. Anyway, so, and the thing I want to say is the reliability and availability, holds at hyperscale. So even at 3,500 nodes, we still have to make sure that the number of instances do launch. You can still have machines fail over and it still works. And all of this still holds at hyperscale. Now, if you want more information about how we actually did this, what's the setup, and some of the more technical details around it, tune into the Service Fabric blog. So in the next few weeks, I will actually write a blog post detailing some of the behind the scenes and what are the things we measured and how did we get to this. So that's it. All right. Now, the other thing I want to show, well, this is what I just showed. Now, the thing that I need people, so it's really cool. 1 million containers in less than 2 minutes, real time, and not just scheduling and placing them, but also launching them. But the key takeaway here is, very few folks are going to be setting up a 3,500 node cluster and running 1 million containers on it. But the key point I want you to take away is you never have to worry about scale again. When it comes to a platform that meets your scale demands, scale should never be a worry. It's your application what you have to worry about. You don't have to worry about the platform. It can meet whatever scale you can throw at it. If it can launch 1 million containers in under 2 minutes, we can do that. Now, the next thing I want to show is, it's not, what I showed you right now is a Linux Docker containers. We've chose Linux because Service Fabric on Linux became generally available as a container orchestrator this week. We announced it at Ignite. And so that's where we set that hyperscale cluster on. I could show the same thing for you on Windows as well and show you the same launches and everything, but wouldn't be that interesting. But what I will show is a cluster, and since we prioritized showing Linux, I didn't set up a 3,500 node cluster because, hey, you know what, that apparently takes a little bit of money and resources. It burns a little bit of core usage. And these are on, so we want to make sure that we are not consuming too much as part of our team, because somebody is going to come by and say, hey, you might want to pay the bill for that usage. So this one is a Windows cluster. I can RDP into one of these and show you that it's Windows, but not too useful. So this is, again, a Windows cluster that has 1,000+ nodes, just to show you that you can. And I just have a couple of dummy applications that are running on it. So it's effectively the same thing. I just want to say it's any cloud and any OS. So it's not just Windows, it's Windows and Linux. You can run these hyperscale clusters everywhere. Now, the next thing I actually want to show is this one. So a lot of folks have actually said, well, I have a Linux cluster and I have a Windows cluster. So I do Linux cluster because I have some Linux-specific workloads, Nginx or Node.js that I like to run on Linux, and I have some .NET Core that I want to run on Windows, or .NET Full Framework that I want to run on Windows. But I have two clusters I have to separate out for it. So can't you make my life easier by not having me egress out of one cluster and go into the other? Answer is, yes, that's a really good idea, and we are working on it. So here, if you actually see here, I'll make this a little bigger. Again, I can SSH into one node, into the Linux node, show you that it's Linux, and then I can RDP into the rest to show you that it's Windows. But I think it's kind of a, it'll be a sad demo for me to show you that. But so I'll let that be. And so you can see that this cluster has 6 nodes. 5 of them are Windows, and 1 of them is a Linux node. So we are working on this. This is going to be available in the coming months. We don't have a date specified for it yet. But when I say any cloud, any OS, it really means any cloud, any OS, and hyperscale. Now, before I move, let's actually now get to this one. So I have something cool that's set up here. I don't know if you guys noticed. And I have to just figure out what number it is. Is it? That's 7. So, Service Fabric is, as I said, you can run it anywhere, and you can run it on-premises or in your clouds. So we have shipped on-premises software on Windows. We haven't yet done that on Linux, but it's coming soon. In the next few months, again, we're going to do that. But meanwhile, when I say we can run anything and anywhere and any OS, what I also wanted to show you is here I actually have a Raspberry Pi setup, an ARM Raspberry Pi that's actually a Service Fabric cluster. There are 3 nodes in this cluster. That's what you see there in Service Fabric Explorer. So we go from the Godzilla SKUs and the 3,500 node clusters all the way down to running a Raspberry Pi. And in order to show you, you can, it's Raspberry Pis, I'm sure everyone's seen it, but you feel free to come and take a photo of it, I guess. But in order to show it's actually Raspberry Pi and it's actually running a container application, we actually have an Nginx server that's also running here. So. And this laptop, the reason I'm using this laptop is because this is now a standalone setup. Excuse me. So it's not really accessible from the internet, or if it was in your data center, what the setup would be, hey, I have a few IP addresses, I'm stitching them together into a private VNet, only I can talk to them, nobody else knows about this, it's all in your data center. That's exactly what the setup here is. It's standalone, and in this particular case, it's Raspberry Pi. We are planning to ship the standalone bits very soon for Linux. Now, with that, let me go to Surface 5 again. And, well, this is what I just showed. Really, because Windows Linux clusters, Raspberry Pi, these things are coming soon, mixed Windows Linux clusters. You can run OS-specific workloads in that particular operating system. All communication can be within the cluster. I showed a Red Hat demo yesterday, so we are also working. Today, Linux is based on Ubuntu, but we are working on a Red Hat distro as well. But with Linux, with containers, you can pretty much run, as long as the kernel is compatible, whatever container images that you want, you can run it on any different OS as well. So now I want to switch to the next part of my talk, which is going to be focused on data-aware orchestration. This is one of the core differentiators of Service Fabric as an orchestrator from others. So as I said, state is something people are only starting to think of. And we've actually spent a lot of time on this, solved a lot of problems on this. And we are going to bring this into your container world as well. So the first thing everybody knows that, hey, you can lift and shift stateless services into containers, and that's what people are doing today. But I'm going to go one step ahead and say, no, you don't have to stop with that. You can even have something like a NoSQL database, or in this case, I'm going to show a demo with SQLite, which has a key value store exposed on it, just to kind of mimic it. And you can have that, even a single instance case, and you can make that highly available with no effort on your part. The platform will have a built-in volume driver that will actually, it's going to ship in the next few months again, that will actually solve that problem for you. So you will get a high availability instance of your SQLite or any NoSQL database, even if it's single instance, and it'll just work. And not only that, the demo after that, what I will show is, hey, single instance, you have it running, very good. How about when I need 5 instances? What sort of heavy lifting do I have to do with respect to partitioning and routing and all that magic? The good news is that's all magic that's actually done by Service Fabric. So when it comes to routing and partitioning, it's as simple as you telling us, hey, you need 5 instances, and passing the lambda that you want to separate out your instances by. Like, okay, is it do I want to separate out my data stores by, say, my alphabet or by some keys? It's up to you to tell us the lambda, and we will actually do the routing for you as well. So when someone hits it from the external endpoint, they're actually going to see, well, it just works. And so it's basically trivial at that point. So let me actually show that first. I think that's the. So again, the key here is there is no replication that you have to worry about, and you don't have to coordinate, what's happening here? How do I scale? How do I scale? How do I do this magic of routing? It's getting complicated. How do I make this highly available? How do I actually maintain the system? It becomes a lot easier. So that's the demo that I'm going to show next. So what I have here is, well, let me make this a little bigger. Service Explorer, as well as I have a UI front end that actually shows what's going on. So I have a voting app, and let me actually show you the voting app as well. So So what I just mentioned is, I hope people in the back can also see this, or maybe I need to make it a little bigger. So I just have a simple key value pair that I wrap up that are basically exposed with a SQLite database. So it's saying, hey, I require SQL, and I have a bit of I have some wrappers that actually do get and set. That's what it does. And what I have here is, essentially, I'm just writing my normal whatever code that I'm writing, a Node.js application with a SQLite database, and this is packaged in a container. So it has a Node.js and SQLite database packaged in a container. This is what I'm running right now, and all what it does is, hey, you can do get voters, and it, as I said, it mimics a key value store, which kind of, if you're using any NoSQL database, that's going to be what you're doing, and you can get, you can put, you can add or delete, you can all do all this. And you set up a lambda somewhere as well. So let me go down to the lambda. So this is the lambda that you provide. Hey, the character of the key is what you're actually sorting by. And we always do automatic partitioning. So what do I mean by automatic partitioning? If there is automatic partitioning and optimization, in the sense, if there is an instance that is running, we make sure that the data is actually right next to that service, so that you don't really have to worry about, my data is on node 5, my service is on node 1, I need to have an extra hop. No, you don't have to worry about that. That's also taken care of. So it's also performance efficient. However, let's actually now go ahead here and show you a demo of this. So what I have here is a client. Of course, it's my browser, which is actually hitting the which is basically hitting the Node.js SQL database backend and reporting what data is stored there. I have a few entries there, Einstein, Galileo, and Newton. If you can't read it, you can add your favorite scientist to that mix as well. And all I have done so far, I haven't changed any of my code. It's still SQLite code, key value service. This is my exact lift and shift scenario. I haven't touched my code, keep in mind. And then I go here, and the only thing I do is I want to say, hey, I want this container to be backed up using, or to be backed by Service Fabric's volume driver. So I go here. I'm kind of struggling with, let me make this a little smaller, and maybe make this a little smaller so you get a little more space. I will zoom it out when I have the page that I want. So I'm going to go into the voting app. I'm going to go into the application manifest. And, oh, come on, just making it a little bigger here. So the line that I want to highlight is this one. Let's make this a little bigger again. So that's the line. What it says is volume source is SQLite, destination is C/demo, driver is SF. So what it's effectively telling Service Fabric is, hey, use the Service Fabric built-in volume driver, and my source that my container is going to talk to is called SQLite, and it is being mapped to a folder C:/demo in the local host. That's all what it's saying. And so what's happening here is, so if you're writing, so generally with the SQLite database or any database, what you actually do is, hey, I back it up to some block store, so to some blocks on my local drive or something like that. But if my disk goes down or if my container goes down, bye-bye to that data. You don't get high availability unless you manage something. In this particular case, I'm just telling Service Fabric, this is what I'm doing, and I'm using your volume driver, so you do what you have to do and make sure I never lose my data. Oh, okay, I'm sorry. I thought it was shifting to my slides. So that's all what I have right now. And so I'm going to go here and show you what it's actually doing. So in this particular case, we have the volume driver actually, oops, didn't mean to do that. We have the volume driver actually as an application type. We will put it as a system service once we preview it or in the next few months. So it's actually a type, and it has a couple of services which will have a volume store gateway. Come on. It basically has a block store gateway service and a block store service. So that's effectively, this is the inbuilt volume driver that Service Fabric is going to ship with. Now, in order to make this a little more interesting, so let me actually go ahead and do this. So I see that the voting app is running on node 2. I have about 7 entries here. And I'm going to go here and just do a failover. So node 2, I'm going to do a restart. Or let's do a deactivate restart. NT1_2. And in a few seconds, what you're going to see is that particular container is going to move from that node to another node. And at this point, what you would expect with pretty much any container, any orchestrator, what you would expect, unless you're backing it through some volume driver or some X store which is sitting somewhere else, is you have lost your data. Let's assume like it's restarted, it lost your data, your data hard drive is gone, something like that has happened. But as I will demo, like once the other now it's migrating that container over along with the data to actually the new node. And once that finishes, you'll find that I still have my data that is available. Now as it does that, let me actually go to, oops, didn't want to show that. Okay. So I also wanted to show, how you would actually, I'll go back to that in a few seconds when it's ready. Make sure this is fine. Yeah. I think it's just missing the. So in this particular case, what I have is the same application, and I showed you the Lambda earlier. I have 5 instances of the same application. And in this case, I split it up into 5 partitions. And when I say 5 partitions, actually what we do is we create, the volume driver actually splits it up into 5 partitions as well. So it's 5 data stores. And in order to show this, what I will actually do is I will demo, in the earlier case with a single instance, I have actually put a delay so that, if I say write something to the database, and if I try to write again to the database, it'll wait, it'll block on it for a few seconds, just to show that's what happens in the real world. If you have multiple requests that are coming in, some of those requests are going to be blocked if you don't have multiple instances, if you just have everything back to a single database. So in this particular case, you will actually see across databases, I can actually add things without really affecting. I get more throughput because I have 5 partitions. I have 5 real partitions that are being created by the volume driver as well. And so in order to create the 5 partitions, all I have to do here is, if I go to the manifest here, I'm not sure why I'm getting all the health query errors, but let's ignore all of that for now. So what I wanted to show here is, in order to create the application, or rather with 5 instances, I have the service. This is the voting app service. Oh, it's just making, okay. Yep, I want to do that. No. It is a secure cluster, and so it's just telling me not to. Come on. Refresh here. So let's wait for it. But meanwhile, let me show the other one. That's what happens when you unplug and your Wi-Fi and you put in the network adapter one. So no, not that one. Just looking for the guy who was showing. Yeah, here it is. Yeah. So here, you saw 7 and it's moved to node type 1. Node type 2 is still disabled. Now, if I go ahead and refresh this, I still have the data there. I don't lose any of my data. It's still there. Boom. I refresh it. It just came back. It's 7 votes, and I can add to it 8. And as I told you, like in this particular case, it's all backed by a single partition. So if I try to add 2 at a time, it's going to block on purpose so you can actually see it. So now when I click on it, it's going to take a few seconds because I'm showing, hey, you can only do one write every X seconds. And so just to show you that, hey, you want multiple partitions when you scale out your service. Now what I'm good, so I just did a failover, and I showed that, hey, I made SQLite into a highly available, now it's actually coming up, the 9, because my delay is now passed. But what I essentially showed in this demo is that, hey, a highly available SQLite database, I just took a SQLite database in a container and made it highly available with the Service Fabric volume driver with no changes in code. The code was exactly the same. I killed a node. The data is still there. Everything still works. And the volume driver will be built as part of the runtime, so you don't really have to do anything either. So you can do this with pretty much any NoSQL database. You can use MongoDB or Cassandra or whatever you want, and you can wrap it in a container, and Service Fabric will manage the state for you. Now let me go to the other one where I have 5 instances. And let's hope that I can fix this. Otherwise, I'll just start a new instance of the browser. Let's see, let's actually close this guy. 50N. Okay, there we are, finally. Okay, so the thing I wanted to show here is, how easy my partitioning was. So I'm going to go to my application manifest. So all I said here is, hey, I have 5 instances, and I want 5 instances of my voting app. So I have 5 instances, and each are running in different nodes. So if I actually went into the node view, you'll actually see the voting app running in all the nodes now. And I'm basically saying my partition count is 5. Let me make this a little bigger. And I've set some key value, 0 and 25. That's what I'm basically partitioning it over. So at this point, I have the same application, 5 instances, and the advantage with this, and again, I didn't have to do, all what I did is I declaratively said I want 5 partitions, and I provided that's all what I had to do. And now I have multiple partitions of the same app, SQLite, same thing, and 5 instances, and now what I can do is I can add here, and I can add here, and it won't block, because you know what? They are all sitting in different partitions. And if, so if you're hitting the same partition, at some point you're going to hit a throughput limit. But since they are spread out in multiple partitions, you actually do get the scale-out benefits. And the volume driver actually does this for you quite trivially. And I didn't have to do any more routing magic other than just provide the Lambda. Now actually, let's actually take it a step, another notch. But let me go back to my slide for now. So as you saw, this is all real time. I'm trying this in clusters in Azure, and it's a real SQLite database inside a container that I just made stateful, and I made reliable and available. And I could scale it out, and you just saw the benefits of scaling out as well. And you didn't have to do any magic there. Completely lift and shift. So that's what I just showed. Now, the key here, one of the things I like to point out here is, the way that we are actually exposing this is there is an underlying Service Fabric state store, which is where, which is what all our state is built on. So the way we expose the volume driver is by having a block store that's built on the Service Fabric state store. And now when you're using something like a SQLite or a MongoDB or a Cassandra, what you have is a data store. You have a front-end service. Your application has a front-end service, and it is talking to SQLite or MongoDB or something in the back end. And that is using the block store, which is using our state store. Now, it is going to be pretty fast because we are always going to place this in the same node that your front-end service is running on. So the block store and the state store, whatever we have, those gray pieces are always going to be running on the same node that your blue pieces are running on. So you're not incurring any additional network hops, so it's going to be hitting your own hard drive, so it's always going to be fast. And of course, it's getting replicated and made highly available transparently without you knowing it. But at the same time, you can see there are 2 hops. So if you really want to hit pedal to the metal, or if you're actually writing a new application from scratch, we have a better answer for you. Now, the one other problem also with this thing is, hey, if say today you are using SQLite or MongoDB, and tomorrow, your company wants to use Cassandra or something else, changing to data store, you have to rewrite a whole lot of code. And to make this simpler for you, what we are actually trying to do in Service Fabric is, when we are providing you with the APIs, we're going to provide you with shims that are very, very similar to what you would use in a NoSQL database. And I'll just show you some code along that. So the idea here is you can use those shims, and you can directly use the Service Fabric state store. So you basically get rid of these 2 hops, the red one and the block store hop. So front-end service will directly start to the Service Fabric state store using some shims that's going to look very similar to your SQL database. So let's actually see the demo of that. And let me shift to here. So let me actually show you the code first. So where's the code? Yeah, here. So this is the one that I earlier showed, which is SQLite, lift and shift. I didn't change anything here. And this is the one where I'm actually going to be using Service Fabric reliable collection. So I'm using the Service Fabric data state store directly, not going through the block store indirection and the SQLite indirection. So, and this will be running in proc. So all the more, like when it comes to performance, this is going to be the one that's going to be really performant. And also, if you're writing new applications or building new applications from scratch, this is probably the one that you want to use because it's going to give you the maximum performance. And you're not really tying into our technology as much because as you see the shims, they are like any other key value store. It's going to be very straightforward to use. There's nothing much specific here. So if I look at it here, now this was the code that you had earlier with the SQLite dictionary. And this is the one that you have with Service Fabric. As you can see, it's very similar. Like, you're doing get keys in both cases, and you're adding to the Service Fabric dictionary as opposed to the SQLite dictionary. And you provide the Lambda very much the similar way. The Lambda that you provided earlier is what we're going to be using for partitioning this. So in terms of a demo, it's still very much the same demo that you saw, except that it'll be a lot faster. I don't have perf numbers here, but this one is actually showing 5 partitions, using reliable collections, and this is just bypassing the volume driver. And you can see there's no volume driver app here because we are not using that. We are just directly hitting the Service Fabric state store. So this is going to be most performant and most efficient because it's going to be running in proc. And it also, if at any point when you have to actually switch databases, this is probably the one that you should use because then you're database agnostic. You really don't need, unless you need an RDBMS, you don't need another data store. Service Fabric has it built in the cluster, so you might as well use it. And and it's highly reliable and makes it available. Okay, now I'll switch back to my slides. So you saw the demo of this. Maximum performance, you use the Service Fabric state store. And these things are coming soon. So the key takeaways that I want to bring out here is, why would you choose Service Fabric? It's a fully integrated and supported platform. The code is controlled by us. And if you run into any issues anywhere, whether it be leader election, whether it be monitoring, whether it be high density something, it's one place to call. We own that PaaS solution. We own the end-to-end solution. You can call us and we will fix it. And it's battle hardened because Microsoft pretty much runs on Service Fabric. All the first parties that I showed you earlier are all running on Service Fabric. And Microsoft continues to innovate on this platform. You can run anything anywhere, and by run anything anywhere, I really mean it, like across OSs, across languages, across frameworks, across even different app types. By app types, I mean you can run Service Fabric services that are built using our programming models. You can run containers. You don't want to run containers, that is also fine. We actually allow you to run executables natively as well. So we call them guest executables. You can run them outside of containers too. It is the only data-aware container orchestrator that is there which will meet your data needs. All your data needs is the only data-aware container orchestrator, and data is highly optimized. We make sure that it is always placed in the same node that your front-end services are running on. Or better still, if you're using our state store, we actually put it inside your service. So we make it in proc. So that's always going to be faster than anything else. So it kind of eliminates the need for a whole layer of complexity that you normally add to your applications. And when I say lift and shift, it's not just lift and shifting of stateless services, but you can lift and shift your stateful services too, your state stores as well. And we will make it highly available without giving you any of the replication pain. And of course, there's a bunch more reasons. Like if you want to start writing a cloud-native application from scratch, we provide you with programming models that let you do that, with an IDE, whole bunch of networking features, yada, yada, yada. So at this point, the question is not so much why choose Service Fabric. I would actually pose the question in reverse, why wouldn't you choose Service Fabric? It's giving you everything, and it's managing all these things for you. So there is really no good reason not to choose Service Fabric. And Microsoft is continuously innovating in Service Fabric, like you look at some of the features that are coming soon, and we're continuing to push the boundaries. Raspberry Pi, this is the first time we are actually showing this. Red Hat Enterprise Linux, we showed this yesterday. The million containers that you saw, all this, it is heavy investments that you're actually making in this platform. So the things that are coming soon in the next few months, the Service Fabric State Store, which you can use with any container. We already have our programming models that are out there, which uses of State Store, but we want to make it very easy for you to lift and shift your existing containers and just use the Service Fabric volume driver, or use the State Store directly if you want to make minor tweaks. Things that are coming, Windows Linux cluster, support for Red Hat, standalone Linux, so you can run it on premises. Again, on the networking side, VNet per application is something I mentioned. Also, we're going to have, today we have dynamic IP per container, so every time the container dies and comes back, it'll have a different IP, but it'll be listening to the same port, so you can put all of them in the same cluster or even the same node. But we are taking it one step further and saying, hey, we'll make that IP also stable. So even when a container dies and comes back on some other node, it will still have the same IP. So the advantage is, hey, if you did some initial configuration, like for example, if you're setting up a HD Insight or something, a cluster on Service Fabric, and if you want some config parameters that you need to control, well, the IP is stable. Once it's up there, it's always going to be that IP. And a whole lot more features that are coming up. So as I said, we are continuing to investigate in this. So in summary, Service Fabric is Microsoft's best-in-class, battle-tested and hardened container orchestrator for both, orchestrator for both containers and microservices, and for any cloud in OS, and it's the only data-aware platform that's out there. A whole bunch of related talks here. I think today there's a talk that is going to be given later today on managing Service Fabric clusters. What are good practices there? And I think many of these talks will be made available online as well. So we have a whole lot of resources out there. So there's an introductory video that tells you the story of Service Fabric in under 4 minutes. See, even it's kind of odd that the story takes 4 minutes. Containers, orchestrating a million containers took just 2 minutes. You can download the SDK, start building applications, a whole lot of tutorials, videos, blogs, samples, everything there. There's a party cluster that I showed you, which you can use to create clusters. And you can always get a production cluster. Please evaluate the session if you enjoyed it. We'll appreciate it. That's pretty much all I have, and I can take a few questions. Thank you.